All right, welcome to day 2. We're going to go over section 12.3. Again, make sure you guys are in the Schoology folder. If you found your way here, obviously you've been in the Schoology folder. Just make sure you guys are doing everything that's in that daily agenda. You should be looking for that green check mark on the daily folder. I'm not saying that this video is completely mandatory, but it is the best way to get an understanding of the notes rather than just looking at the completed notes. So just know that this resource is here, but if you're somebody that can just follow along in the book and look at those answer keys, feel free to do so. Just take advantage of any of the office hours that I have if you have any questions. So let's get started. All right, so 12.3. Oops, that's not the beginning. 12.3. So as we finish up, this will be the last section in chapter 12. We're going to talk about inscribed angles and intercepted arcs. So we're still talking about those polygons and angles and chords, everything inscribed inside an angle or a circle. So an inscribed angle. It's an angle whose vertex is on the circle and whose sides are chords. So we can actually see that down here. So this is an inscribed angle, meaning the vertex does not have to be at the center of the circle. That would be a central angle, and that's what we dealt with in the last section. These are inscribed angles, so angles that go from one side of the circle to the other side of the circle. When that happens, just like we created an arc earlier, an inscribed angle creates an intercepted arc. So an arc with endpoints on the sides of an inscribed circle, inscribed angle, and its other points in the interior of the angle. Keep in mind, a lot of these definitions are more complex, hard to visualize. Once you visualize it, it's a little bit easier. So basically we have our inscribed angle, and so here's the intercepted arc. Here are all the points that are on the interior of that inscribed angle, and then here are those endpoints that we're talking about. And that brings us to our first theorem here in the section. So the inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc. So the measure of angle B equals 1/2 arc AC. So quick example, if this was 120 degrees, that means this would be 60 degrees. So anytime we get to a problem, if you want to pause it and then try it yourself and then press play to see if you got it right, feel free. I'm just going to keep moving, so I'm not going to purposely pause because you guys can pause it yourself. So we're looking for the values of A and B here. So if I look at A, A is the intercepted arc of the inscribed angle PQT. So that means that the measure of angle PQT is 1/2 of arc PT. And arc PT is A right now. So 60 degrees equals 1/2 of little a. You can solve that, or you can just solve algebraically or solve that logically. That's going to tell us that A is 120 degrees. If we're looking at B now, B is the inscribed angle PRS. So the measure of angle PRS equals 1/2 of arc PS. PS is different than arc PT. PS goes a little bit further. So this is saying that B equals 1/2, and I'm saying B because B is this inscribed angle. So I'm basically using the substitution method right here. So B equals 1/2 of PS, and PS is A plus 30, or 120 plus 30. So B equals 1/2 of 150. So B equals 75 degrees. Hopefully those colors help you out more than if you were to look at the black and white key. Again, you're going to benefit most from watching the videos than looking at the keys as a static example. Again, try the next one yourself. Go ahead and hit pause. So in circle O, what is the measure of angle A? So the measure of angle A is going to equal 1/2 the arc. Now we don't have endpoints. I'm going to put some on here real quick. CD. And think about what I highlighted right there. I went from one end of a diameter to the other end of a diameter. So that means it's a semicircle. So that's going to be 180 degrees. So the measure of angle A equals 1/2 of 180 degrees. So the measure of angle A equals 90 degrees. So notice we made a little right triangle there, and that's going to show up again right down below. So we have some corollaries. Corollary 1. If you have two inscribed angles, and I'm going to see here if I can highlight them for you. So you have A and you have B, and we're saying that they're congruent. And notice they represent the same arc, the same intercepted arc. So the corollary says two inscribed angles that intercept the same arc are congruent. Corollary 2, an angle inscribed in a semicircle, just like above, is a right angle, which creates a right triangle, which here comes the Pythagorean theorem. Not too much to kind of annotate over for number 2 there. Corollary 3, the opposite angles of a quadrilateral inscribed in a circle are supplementary. So here's what we mean by that. So angle A and angle C are opposite angles. We are saying that those angles are supplementary, same as these two. And we can do a little proof of that just looking at it. If I talk about angle C, angle C is that intercepted arc. The opposite one, A, notice how it complements that. Together, both of those arcs make up the full circle, which is 360 degrees. Since the inscribed angles are half of their intercepted arc, they would be 90. So they would add up to 180, basically half of the 360. It doesn't mean that they're 90 and 90. Doesn't mean that red and green arc is 180 and 180. We're just saying that they do add up to 180 degrees. The arcs add up to 360 degrees. All right, let's put these to use. What is the measure of each numbered angle? So angle 1. Notice that the inscribed angle we have the intercepted arc being a, oops, not green, a semicircle. And the reason we know it's a semicircle is because the chord is actually the diameter. Since it's a diameter, it cuts that circle in half. So corollary number 2 above says that number 1 is 90 degrees. And that's the only numbered angle. The directions made it seem like there'd be more. All right, number 2. Okay, number 2, we have this inscribed angle which is the same intercepted arc by this inscribed angle. Therefore, corollary 1 says if that happens, then the measure of angle 2 is also 38 degrees. All right, so now we have 4 angles that we need to find. First thing that jumps out at me is I am shown this diameter. So that means this semicircle is the intercepted arc, meaning angle 1 is 90. And corollary number 3 says the opposite angle is supplementary. So we know that the measure of angle 1 plus the measure of angle 3 equal 180. So that means that the measure of angle 3 must also equal 90 degrees. You can get at that using corollary 2 for both of them. You don't have to use corollary 3 to think about it that way, but that's what they want you to think here. All right, let's look at 4. For the inscribed angle, so the measure of angle 4 equals 1/2 60 plus 80. So that's 70 degrees. And then again, corollary number 3 there, we have the measure of angle 2 plus the measure of angle 4 equals 180. So this is the measure of angle 2 equals, and you can think of this a bunch of different ways. I know a lot will just do a little bit of subtraction right there. $110. All right, last theorem, nothing really fancy. Since we don't have an inscribed angle right here, what it's telling us is if you have an angle formed by a tangent, meaning the other side of the angle is actually going to the exterior, it's going outside, but it is tangent. And a chord for the other side of the angle then again it's half. So really nothing different here. We're just saying that this angle right here is still half that arc. Now this has to be tangent. Okay? Can't be like this. Has to be tangent. So if that angle was any smaller, it would be a chord. So basically that's the widest that angle can get before that 1/2 property does not hold true. So in the diagram, again, they're telling us SR is tangent. If PMQ is 212, PMQ is 212, what is PQR? So if PMQ is 212, oh, I actually diagrammed that incorrectly. My fault. I was going to say that's a little too easy. PQR is this angle down here. PQR angle. Sorry, I thought it was an intercepted arc. So if that's 212, that means that the measure of angle SQR is 1/2 of 212. So the measure of SQR equals 106. And since that blue angle that I have there, PQR, they're a linear pair, so they are supplementary. That means that the measure of angle PQR equals 180 minus 106, which is 74 degrees. We actually can get to that answer the way I was thinking of it before. If this is 212, we know the rest of the circle has to add up to 360, which means it's 148. And then this angle is 1/2 of 148, which is 74. So there's two ways to think of that. Go ahead and pause it and try the next one, which will be the last one, before we go ahead and attempt it. All right, in the diagram at the right, KJ is tangent. What are the values of X and Y? What are the values of X and Y? So what we can see here, the thing that jumps out at me first, is we have a diameter, which means that's 90 degrees. That's corollary 2. So corollary 2 says that angle QJL equals 90 degrees. And since that is 90 degrees, then we know that Y plus 35 plus 90 have to equal 180. Theorem 311. That means Y equals 55 degrees. If we zoom in here and we look for angle X is right in here. It's also, we can call it angle LJK. LJK, that's angle X. It's made by a chord and a tangent line. So it's associated with this arc. And notice that arc is associated with this inscribed angle. So that means arc JL equals twice .35. So if that arc is if that arc is 70 degrees, that means that X equals half of arc JL, which does seem like we're going backwards, but as we can see here, that X and 35, we didn't know how they were associated until we realized that they are given the same arc, intercepted arc. So that means X equals 1/2 of 70, which gives us back 35 degrees. There are other ways to do that problem. You might have seen a quicker way to do it. You might have taken a longer way to do it. There's a way to do it using the entire circle of 360 degrees. Would be just a little bit longer to find this red arc, but it's all in how you see it. Pay attention to those homework problems at the bottom. Make sure you guys tune in to any of the live office hours. Contact me via email, go in the Google chat room, and make sure you guys do that exit ticket at some point in the day. If you want to wait until after it, maybe you're doing morning office hours or evening office hours, and you want to do that exit ticket after your questions have been answered, that's perfectly fine. Just make sure you have that all done by the end of the evening, mainly midnight. Midnight's whenever I'll roll everything over to the next day. And we will be having two things. We'll have a review day. We'll do a live review day, and we'll have a homework quiz coming up that will be on Schoology. Okay? Make sure you contact me with any questions.